Hello, my name is KOLLITZ, and I'm here today to give you a rundown of what the KOLLTEK system is about. I was at a trade show at AIM Expo a couple months ago and had the opportunity to speak to a lot of people who stopped by and took a look at this guy back here. This razor has the KOLLTEK 1.0 system on it, and so I got used to explaining what it is, as a lot of people looked at it and they scratched their heads trying to figure out what's going on. And it's really difficult to send an email with a picture and have people understand what's happening, so I thought I'd do this little video. So I have with me a model. So I'm going to do a little close-up here and you can see what's going on. Now, in most vehicles, this is what you have. You have 4 shocks on 4 corners, each shock having about 25% of the weight of the vehicle that's responsible for, right? Well, with the KOLLTEK system, we connected them all together. This is no electronics, no CPUs, no sensors, no nothing. It's all mechanical, and it connects diagonally across the vehicle. Let's call this the front down here, okay? So it connects the front, in this case the front right, with the rear left tire, which provides it all kinds of advantages, and I have a long list of them here to the right. So it's nice thing about doing this close up, you see my model, you don't see my face looking over at my notes, so I can make sure I cover all the points. I don't want to leave anything out. So what we have here is we have a shock that's responsible for 25% of the weight of the vehicle on the corner, right? And as you lift up, you can see the left rear also going up. Well, the center shock here is responsible for 50% of the weight because it has to carry both the loads from both corners tied into this in series, right? So what we have here is this shock is responsible for half of the wheel travel, and this shock is also responsible for half of the wheel travel of this wheel and also of this one back here. What that gives us, it gives us a lot. Okay, now I'll go through the attributes as I go through the different benefits of the system. Because so let's start with cornering, right? And this is where this came from. I developed a suspension system for my ATV, and it had great anti-roll characteristics, but didn't have very good articulation, and this solves both of those issues. So, right front, I'm going to turn. What happens, the right front starts to compress, it lifts up on that left rear, right? So what does that do? That brings that left rear of the vehicle down. As you come into the corner and both sides start to compress, the inside of the entire vehicle settles down into the corner. So it provides a nice anti-roll capability. How much it rolls is dependent upon how you specify the shocks. How much wheel travel do you want to take up by the corner shocks? How much do you want to take up by the center shocks? What type of valving? How soon does it transfer from one to the other? The spring rates, of course. If you have dual springs down here and dual springs up here, you can set them up so it engages early, engages late, whatever. These are all variables that you get to play with to set up the suspension for the application for which you're designing it for. So that's anti-roll and cornering. Now what happens when you throw on the brakes, right? When you throw on the brakes, the back end lifts up. So it drops the whole back of the vehicle down. Same thing, when you get on the gas, back end wants to squat, right? Well, as it squats, it drops the front end down. So it has this anti-roll, anti-lift, anti-dive features all figured into it. So that comes into, now for off-road, that's why I designed it for, because I race off-road. And this covers the gamut. So off-road, on-road, it doesn't matter. These attributes are all the same. It just depends again on which market you're going into. But for off-road, if I'm going to go up a hill, let's say this is the back end, right? I'm going up a hill, all the weight comes down on the back. What happens when it comes down on the back? It brings the front end closer to the hill, so you can actually go up steeper hills without tipping over, which is kind of a nice thing, right? And here's another thing, it also gives you more supple suspension, because as it compresses, these center shocks are taking a lot of the load. They're taking half the load, half the wheel travel, which still leaves the corner shocks to find the curves of the surface of the ground and go over it quite easily without being squished like you would if it was all the weight weighing down on it. Same thing going downhill. If you're going downhill, the front end starts to compress, it brings the back end down, so you have steeper downhills. Same thing with side hill. Okay, same thing. The downhill wheels will compress and it brings the upside wheels back down to the mountain. So you have a much steeper angles you can side hill on before you roll it. Now let's keep it on the positive side of that and not put your tires up in the air. So it doesn't matter what you're doing with stopping, accelerating, turning, going up a hill, going down a hill, side hilling. All these attributes come into play, and all these are improved because of the system. So we talked about anti-roll. Well, now let's talk about articulation, right? Sway bars are the killer of articulation, and they make the ride rougher, but they give you performance going around corners, so they're a necessary evil. And you're always trying to compromise between the how tight you want to make the anti-sway capability versus how comfortable you want to make the ride. With this, you don't have that. Here you have full compression, right? Full compression on here, full articulation. This side can come up to get the full compression on a diagonal. So you have full articulation, yet you still have full anti-roll capabilities built in the system. Off-road, still off-road. One of the things I like to do, I like airtime. So what happens with airtime, when you have a typical system where you only have 25% on each wheel, what happens when you land in the air, you have 100% of the weight of the vehicle coming down on the front end, right? That's only 50% of the load carrying capability on the front, 2 shocks, right? And the back end is just up in the air. Well, with this, as you hit the ground with the 2, these shocks take up 50% of the capability of the vehicle. So half the stroke is 25% for sure, so that's 50% total. But then both of these are also being engaged, so that's 50% times 2. So that's 100% of the load carrying capability being put up to the front end that's engaging the ground. So you have a lot of variability depending upon what's happening here. If it sits equally on the ground, that's 25% per tire. But if you're only on one side, that's up to 50% on the tire, and 2 of them, 100%. So smoother rough roads is my next. So this is number 9 attribute benefit. Number 9, smoother rough roads. Well, again, 25%, 50%. What happens with this is that you have the compression valving and the rebound valving set for this shock, for this spring rate, for 25% of the load. Here, it's set for 50% of the load. So it's a stronger compression, a stronger rebound that's set appropriately for that spring rate because of the weight it's carrying. Now, in a typical system, you have to set this shock to account for everything, right? So you either set it too soft, so when you hit something hard, it goes through the whole stroke, or you set it too stiff, so when it's going over the small stuff, it's a rough ride. This has the capability of carrying both those attributes no matter where you're at. So you're going to experience a smoother ride here and still have the load carrying capability up here. And I'm not sure which attribute of mine on my list this is, but watch this again as I do this. Okay, so you have the small movements going on here, the quick movements, the quick rebound, and yet that's not transmitted to this one because of the compression valving, because of the rebound rate. So it doesn't matter how deep into the stroke you are, you'll still have this wheel staying in touch with the ground, giving you that control instead of in a typical system that you're hitting hard. This one's set up with a slow rebound rate. It's skipping over the ground. Of course, when you're in the air, no control, no braking, no acceleration, no turning. Next attribute is greater load range. Let's take a look at this from the side. Okay, let's say this is a utility UTV or a pickup. What happens when you put a lot of weight in the back of a UTV, right? You squish out that suspension, it completely compresses it, and the front end's riding really light. Well, with this system, as it starts to compress, it's bringing the front end down because these are taking the weight. It's not all being transmitted through the rear shocks there. So because these are taking a lot of the weight, it settles the whole vehicle down and still allows for movement in the back with the same amount of weight on this versus a typical system. So much better load carrying capability. That also includes live load. So of course a pickup is live load, but let's say you have a 4-passenger UTV and you drive with just yourself in the front. That's not very much weight. It can handle that no problem. But let's say you put 3 more people in there. Well, that changes the whole vehicle, the weighting of all the tires. Well, these shocks handle the weight of the whole vehicle. So it doesn't matter where you place that weight, these shocks are going to take it. Now, these on the corner are still going to have a little bit of that, but this is going to account for a lot of it. So it's going to reduce all that, what would normally be an adverse weight distribution is being greatly reduced with these center shocks in here. Let's see, shock absorption directed to the wheels that need it. I spoke about that a little bit earlier with landing on two tires from a jump. Even if you land on one tire from a jump, what happens? Let's say let's get out of the off-road thing, which I love, and just talk about on the road. You're driving down the road and you hit a curb, right? Bam. What happens is that the full weight of the vehicle is behind that hit. So this shock is set up for a lot less impact than that. But because it has this shock up here, it can greatly progress from 25 to 50% and greatly reduce the impact and shock that's going through the vehicle from that impact that you're having. Less energy to go over obstacles. I love this one. This, talk about changing vehicle dynamics. So you have the front end of the vehicle here, right? Typically what happens when you hit, let's say you're going to go over, off-road, 1 foot rock, no problem, right? What a 1 foot rock does, it lifts up the front end 1 foot. It pivots on the back and it lifts up the whole vehicle. It's lifting this whole mass upwards to accommodate that 1 foot rock you're going over. With this system, as this starts to compress, let's get this so you can see there. So this diagonal tire is being pulled up, which allows the whole vehicle, let me get back here so you can see, or at least so I can see and do it correctly. So as it compresses, it's lifting that diagonal tire up, which makes the whole vehicle pivot on the back. It drops the back end down. So the front end's lifting up, the front corner is lifting up, and the back corner is dropping down. So what's happening is that the vehicle is pivoting about the center of the mass, diagonal center of mass, as it goes over that obstacle. So instead of lifting the whole vehicle right up here, I'm sorry about the, the views there. So instead of lifting the whole vehicle from the front, as it starts to lift, it drops the back end, so it creates a pivot motion about the center of mass. So when we talk about energy, amount of energy required to go over something, a lot less energy required to go over an obstacle that way. The backside of that is after it comes down, it has a lot less energy that it has to absorb to go over that same obstacle to stop that movement of it coming back down again. So it does this because it acts through the center of mass of the vehicle. It acts on both sides of it. Typical suspension just acts on the front or just acts on the back. It does not act across both sides of that center of mass. So this is really where a lot of the benefit of this is coming from. Let's see, I already spoke a little bit about less rebound or suspension packing because of the dual rates, because the compression and the rebound is set for the weight and spring weight, the spring rate and the weight of the vehicle. 50%, 25%, it's not as likely to pack. Again, it's going to follow the contours of the ground so much better. So it's just such a better setup that way. I'm reading my list here. Give me a second here. You have heat being dissipated over 6 shocks instead of 4, so you have more heat dissipation. And I'll in Crosslink 3.0, there's a little different configuration, but the principles still apply. Let's see, of course there's less stress and strain on the vehicle because you're able to do much greater range. The shock is able to handle a much progressive range from 25 to 50% as opposed to just compromising with the one typical 25% load. So a lot less impact going to the vehicle and a lot smoother ride for the occupants. It's compared to, I have to make sure I put that in there, compared to other advanced systems, this is a low-cost solution, right? It's all mechanical, very basic. In fact, your typical system has a sway bar in front and a sway bar in back, right? What's a sway bar? Piece of spring steel and a couple of links. Well, what do you see here between this corner and here? You have a couple of links and a long piece here, and it's not even spring steel, right? So your componentry, the amount of mass that you're putting in there is pretty similar. You're just adding an extra shock. In this case, in 1.0. Now 3.0, different configuration, and we'll cover that and the advantages that that brings to the table. Let's see, instant response. You don't have to do any processing, send signals, have solenoids activate and stuff, so everything's instant. Regular shocks act like premium shocks. These can be monotube shocks, basic monotube shocks. This could be a basic one on the corner. This one is just handling twice the capacity, so it's built a little stronger, but still just a basic shock. But what it's still doing, it's still doing that weight transfer. It's still acting across the vehicle. It's still providing all those other benefits that you get that I just went over with the system for very basic shocks. Now you can put the expensive shocks in there. You can put the ones that have the great valving and the great ride characteristics. It, of course, just increases the cost of the whole system, but you know where that goes. So you can be very basic and still have a lot of value, or you can continue to add a lot of capability with the quality of the compression and or the valving, the compression and rebound valving that goes in here. By the way, that also applies to electronic systems. If you want to put live valving in here or active valving, you can. You can do that. You can bump up the capability of the system that way. Of course, you're adding a lot more cost at that point. So the cost for value proposition is changed when you go there. But this one gives you a lot of value for very little additional cost. Where else are we at on my list? Performance, of course. We talked about performance. That's everything. It increased comfort, safety, reliability. There's nothing new underneath the sun here as far as shocks are concerned. Okay, it's all proven capability out there. No specialty equipment for your service technicians or service departments. No specialty training. Anyone can pop off a shock and pop another shock on. With 3.0, there's a little more involved, but nothing again that's requires extensive training to address. So that's a mature product and manufacturing technology that goes into this. So that basically is the Crosslink system. Okay, now this is, like I said, Crosslink 1.0 and 3.0. What I did here, so obviously there's issues with this, and this is why I initially thought this was a manufacturing deal. The manufacturer would have to design this into their vehicles to accommodate all the mechanical linkages and such. But we had a really good response from a couple of the OEMs at the Power Sports show, and I laid up late at night thinking, how are they going to design around this? Of course, I don't want to do that because I want to make some money off of my thought process here, right? So what I did was I was able to retain all the capabilities of the system, but I eliminated all these linkages. I eliminated the links. I eliminated the center shocks. I took all this capability and pushed it out into a new design of shocks. So so it comes down to just 4 shocks. That's the new system. 4 shocks. They bolt in the same place they did before, but yet they do everything that this system does. So Crosslink 3.0 does everything that this system does with new design shocks. So that's Crosslink 1.0 through 3.0. And this here is the Razor. You can see we had it set up for 1.0. This here, top of the shock, pivots up and down. You have half of your shock travel down here, half of the wheel travel down here. This movement, this other amount of movement comes from the diagonal shock over there on that corner. And same thing with this. This comes from the diagonal shock over there. So obviously this was a retrofit of an existing vehicle that had not been designed for the physical space requirements that this system needs. So we have a lot more going on here than it should be. It can be, if designed from the start, as simple as a couple of links, a long piece going from front to back, an extra shock. Now this shock, I have it shown, designed, or sitting right here in the middle. It doesn't need to be here. One end needs to be affixed somewhere to the frame of the vehicle. The top attached to this piece can be anywhere between this point and this point. As long as it's attached somewhere between there, it's doing its job that it needs to do. So like on the Razor, I know you can't see it from here, but you'll see it in some other pictures that'll accompany this. The 2 shocks, or the center shock, is actually connected closely to the rear corner shock, but it all acts the same way. These 2 shocks are in series. They're in parallel to each other and both in series with the center shock. That's it. If you have any questions,